Hi, I'm Xiang, a final year computer science student working on a project Capture the Flag Challenges Design and Implementation. There are four sections in this presentation: Introduction, Methodology of the project, Results, and a conclusion. First, an introduction of the problem statement. Capture the Flag, also known as CTF, is a cybersecurity competition where players have to solve cybersecurity challenges in order to win the game. Among the competition modes, the Jeopardy mode is popular in the cybersecurity community. In this mode, players have to discover secret texts called flags by exploiting software vulnerabilities planted by the challenge developers. By incorporating cybersecurity concepts into a game, CTF can be used to enhance the theoretical cybersecurity knowledge learned in the classroom. For instance, educational institutions such as New York University, UCLA, and Carnegie Mellon University organized CTFs. Similarly, in NTU, the software security module CZ4067 also incorporates CTF as 20% of the student's module grade. In this project, there are two objectives: software deliverable and report. To ensure a constant stream of CTF challenges for the software security module, challenges have to be designed and created. The second objective is to facilitate the creation of these challenges. This also includes examining the design and implementation of challenges to help future CTF developers of this module create challenges that cater to the module takers, are engaging and interesting from ideation, design until testing. To achieve this, several techniques were used. To really complete a challenge, a developer has to ensure the design, implementation, release, and testing of a CTF challenge is completed. In the first phase, design, a challenge developer has four aspects to consider. Firstly, he needs to include relevant topics that the module takers can comprehend, yet intrigue them with common real examples of software vulnerabilities. Therefore, while the challenge topics should be based on a module syllabus, they should preferably be related to the common vulnerabilities, such as those listed on OWASP Top 10 and the Top 25 CWE, which list the common vulnerabilities and weaknesses in software, either on web applications or in common software. Secondly, a challenge should be assigned to various difficulty levels to engage students from a wider range of skill sets. A few considerations should be factored while estimating the difficulty level: whether a challenge has many concepts, whether specific exploits or tools need to be used, whether source code is given, and whether the module concepts are extended in this challenge. In this project, there are three levels: easy, medium, and hard. Thirdly, a challenge should have a category and mode. Binary exploitation, also known as PON, and web exploitation challenges are included as they are the major components of this module. Forensics challenges are included as they introduce students to more CTF challenges while having low overhead for students to learn out of the syllabus. All challenges, except some forensic challenges, require students to interact with the organizer's servers to obtain the flags. In the second phase, implementation, the challenge developer codes the software and prepares the necessary artifacts. A few techniques are useful in this phase, specific to CZ467 CTF developers. When designing any challenge, especially challenges where source code is reviewed, use programming languages NTU School of Computer Science and Engineering students are familiar, such as Flask framework, C language, and Node.js framework. This is because this module is meant to teach students the general ideas of software vulnerabilities, not to a specific language. For deployable software, make them containerizable, such as using Docker, as this will help the competition organizer to develop the challenges easily, deploy them, and the distributed source code can be run on the students' machines. Specifically for pawn challenges, create network instead of static challenges so that flag obfuscation is not needed, as students might be distracted to crack the obfuscation instead. As an attacker can reverse shell a server running a binary program, use jailing to limit the player's activities. Meanwhile, web challenges that involve cross-site scripting attack or XSS may require the server to check if the attack occurs. JavaScript obfuscation and framing can be used to review the flag for reflected XSS attacks, whereas headless browsers can be used to simulate the victim of an XSS attack. CAPTCHA can be implemented in case a player abuses the website functionalities, and the server database should be regularly cleaned if user details are logged. When the challenges are deployed for competition hosting, it is advisable to have at least two clusters. The first cluster is for the competition platform for handling administration issues. And the second cluster is the challenge cluster, which will host all of the challenges. By separating these two clusters, we can ensure that the CTFD platform is always available because the challenge cluster is prone to attacks. In the third phase release, administration aspects play an important role in helping module takers, who are mostly cybersecurity beginners, to enjoy a seamless CTF playing experience. At the very beginning of the competition, distribute handouts to students. To help cybersecurity beginners, include exploit templates and links to useful tools. During the competition, observe the students' performance based on soft statistics and drop hints if the challenge appears too hard. However, just like challenges, hints should be tested to ensure they are helpful but not too outright. Additionally, impose a submission limit to reduce brute force guessing of flags. At the end of the competition, official write-ups should be distributed so that students can learn about the vulnerability detection process and improve their CTF and practical skills. To identify potential server or administrative issues, a feedback form should be distributed to students right after the competition so that future CTF developers can take note. In Phase 4 testing, the challenge developer should have developed the challenge, complete with a write-up and solution script. To gauge the suitability of this challenge, a competition trial should be tested, and preferably on CZ467 students, the actual participant pool. This brings two benefits. We can ensure if the vulnerable container crashes unexpectedly, and we can more accurately estimate the difficulty level of this challenge based on soft statistics. After the trial, distribute a survey to capture student sentiments and profiles. Among the survey, key information like the student's educational profile in cybersecurity, their perceptions of the CTF challenges, and any administrative issues such as misleading hints or irresponsive servers are useful feedback. The development of a CTF competition requires a constant stream of challenges and many CTF developers. That is why it is crucial to have a structured challenge bank repository. Here, we propose one such structure where one challenge will have 4 folders corresponding to the 4 stages: development, deployment, solution, and distribution of artifacts. The challenge bank repository should also have continuous integration, which is run on GitHub Actions in this project to test the Docker containers and the correctness of the sample solution scripts. With this workflow, the competition organizer can be more assured of the stability of the vulnerable software, the correctness of the solutions, and onboard new CTF developers in the long term. With all of this methodology, we proceed to the actual results. In this project, 7 binary exploitation, 6 web exploitation, and 3 easy forensic challenges were developed in the past year. And some of them were tested in the competition trial among the CZ467 students in the second semester of academic year 2022-23 for 1 week, involving 10 challenges and 82 players. A few insights were obtained. Firstly, interesting challenges should be created, but to be engaging, they need to be solvable within the competition timeframe with slight research. Secondly, challenges that attempt to expose students outside the course should go in breadth. Thirdly, good administration is needed even during the competition, such as having clear hints, correctly estimated difficulty levels, and the release of official write-ups. Fourthly, always ensure the challenges are available, either with constant monitoring or having orchestration services such as Kubernetes. In conclusion, 16 challenges were developed in the standardized challenge bank repo with CI workflow. Additionally, CTF challenge developers for this module should design challenges with students' profile in mind, expose them to common vulnerabilities, and test their products, including solution and hints, before the competition organizer uses them. With that, I thank you for your time.